So I've been doing a lot of content about the problems I have with power scalars, and I don't want this to turn into a power scalar hate channel. That content is very negative, so I want to do some positive content. I want to show you why it's actually really cool not to just pick and choose laws of physics. Because when you chase down the rabbit hole of how physics change in fictional universes, it can be really interesting. Let's use Dragon Ball Z. Everyone likes talking about Goku. The first thing any anime fan will tell you is that Goku can move faster than the speed of light. Wait. Relativity tells us that's not possible. But we do see Goku moving faster than our speed of light. Which, if physics still held true, it would mean in the Dragon Ball universe, Goku isn't moving faster than light, but rather the speed of light, aka the speed of causality, is higher. And this has a lot of interesting effects. The first of which being its link to gravity. If the speed of causality is higher, then that weakens gravity across the universe. See my other video about how gravity and time dilation are linked to the speed of light if you want more info on that. Less gravity means that there's more capability for real superhuman feats. So the big crazy jumps that the characters do, the flying, that becomes more plausible. And then there's the famous equation E equals mc squared. Energy equals mass times the speed of causality squared. If the speed of causality goes up, i.e. has a higher maximum, then the energy you get from mass ends up being much larger. Which means that all of these crazy energy blasts and ki blasts and stuff like that would make a little bit more sense because you would get a lot more energy from a lot less mass. And that's just the tip of the iceberg. We can go into how we see in scenes that Ki, when entering Goku when he charges a spirit bomb, enters him via curves that look like a magnetic field. Which means whatever particles Ki is made of must have some sort of quantum spin. And all of these, of course, need to be hashed out and thought of, and there's a lot more holes that need to be patched and a lot more reasoning you need to do, but that's the fun part. The thinking about it is the fun part. And these are conversations I don't get to have if you pick and choose the laws of physics. And I want to have these conversations. They're really interesting. Probably a little crazy. I'm not even going to do the math on them because the math is probably going to be inaccurate, but in terms of just theorizing how different fictional universes operate, it's really cool. And I want to do the really cool thing. You guys should do the really cool thing with me. I think it's cool.